Imagine this: the silent, endless cold of space. Somewhere beyond the orbit of our world drifts Mars, a small reddish sphere cloaked in dust and mystery. It seems distant, harmless, forgotten, and yet, every few million years, it reaches across that vast emptiness and touches us. Not metaphorically, not symbolically, literally, through gravity. Once every 2.4 million years, Mars triggers a sequence of cosmic dominoes that reshapes Earth's climate, alters ocean currents, and even stirs oxygen in the deep sea. A discovery that's rewriting what we thought we knew about the interconnected rhythm of our solar system. Long ago, long before dinosaurs, before continents took their modern form, Mars was a different world. It had a dense atmosphere, a strong magnetic field, and rivers of liquid water. Some scientists even believe that life itself may have begun there, and later found its way here. This isn't a sci-fi fantasy. It's a serious scientific hypothesis called panspermia, the idea that life can travel between planets carried by meteorites. And we've found proof of that travel. More than 300 meteorites from Mars have landed on Earth. Locked inside them are clues, traces of ancient water, chemical signatures that could once have been the building blocks of life. Films like Mission to Mars and Prometheus only gave form to something scientists have long wondered. What if we are, in some distant sense, children of Mars, but the connection between our planets runs deeper than shared dust or cosmic ancestry? Earth and Mars are bound together by gravity, an invisible thread stretched across millions of kilometers. Planets are not isolated islands in space. Their orbits, tilts, even climates are tugged and twisted by their neighbors. And between Earth and Mars, this pull becomes a kind of slow, elegant dance. They are locked in what astronomers call an orbital resonance. That means their gravitational rhythms occasionally amplify one another. And every 2.4 million years, the resonance peaks, like a cosmic heartbeat reaching its climax. Earth's orbit tightens or relaxes just slightly, changing how much sunlight reaches our planet. That small shift is enough to ripple through the entire climate system. For decades, this was just a theory, elegant but unproven. Then a team led by geologist Adriana Dutkiewicz at the University of Sydney found the missing evidence. They examined nearly 300 samples of deep-sea sediment cores taken from oceans across the globe. Each layer of sediment is a page in Earth's diary, recording what the planet was like at the moment it was laid down. By analyzing how fast these layers accumulated, the scientists noticed a striking pattern. Every 2.4 million years, the rate of sedimentation dropped sharply. Something was stirring the oceans, preventing sediments from quietly settling on the seafloor. When they compared these slowdowns with computer models of planetary motion, everything lined up perfectly. At the exact times when Earth's orbit shifted under Mars's gravitational tug, global currents strengthened. Those currents mixed the oceans, bringing oxygen to the depths, but also keeping the seabed too turbulent for sediments to rest. In other words, the fingerprint of Mars's pull is etched into the geological record beneath our feet, a silent signature written in stone, proving that even across millions of kilometers our worlds are still connected. To grasp the scale of this influence, you have to remember what the ocean really is. Not just water, but a vast engine of heat and life. When its layers stop mixing, oxygen can't reach the bottom and ecosystems collapse. But when circulation intensifies, life blooms. Every few million years, Mars gives this system a subtle push, a gravitational nudge that warms the climate, awakens the currents, and revives the deep ocean. Paradoxically, without this ancient rhythm, Earth's seas might be far more stagnant, far more lifeless. Of course, this has nothing to do with today's rapid global warming. What Mars does unfolds on geological timescales, cycles that span millions of years. What we're causing happens within mere decades. But the discovery reminds us how delicately balanced our planet is, how its fate is tied to the movements of even the faintest neighbors in space. If the cycle remains stable, the next great Martian pulse will come in about 2 million years. By then, who knows what kind of planet Earth will be? Because now there's a new variable in the equation: us. Humans are rewriting the climate in ways that nature never planned, and we don't yet know how our disruptions will interact with those slow, cosmic rhythms. Will the next Martian cycle amplify the chaos we've unleashed, or help the planet recover? Science doesn't have an answer yet. What we do know is this: Mars is not just a red dot in the night sky, nor a silent stone drifting in the void. It is an active participant in the grand conversation of the cosmos, one that has been going on for billions of years. Its gravity hums in the background of our existence, subtle but constant, like a pulse you only notice when you stop to listen, and perhaps someday we'll learn the full truth. Whether Mars was our cradle, and whether it still conducts the rhythm of our climate. Because if a neighboring world can alter the heartbeat of our own, what other secret connections lie hidden across the stars?